In this video, I'm going to show how a hyperbolic paraboloid can be a surface of translation. So here are just a few sketches I've done to show annotations of this. So a hyperbolic paraboloid can be formed by translating or sliding a downward parabola, so that being our red parabola here, ABC, along an upward parabola, that being our blue parabola here. So you can just see that here then. So as that downward parabola is moving along that upward parabola, it's using that upward parabola as an axis to move. What we can also see as well then, that the vertex B is always staying on this upward parabola as it moves. So we can see that there, and we can see it here then at the end as well. So I just thought there were a good few sketches there to show that. So what I'd like to look at now is this principle here. Firstly, if we look at our right hand side, we have a 3D pictorial with our measurements, everything that the students would need to answer this. I think they'd need a very good understanding of orthographic projection first anyways. So if we look in from our right hand side, what we can see is an edge view of our parabola ABC. So that's given by that line here. We can see the upward parabola here. So that's the upward parabola in here. So that upward parabola is the parabola which the downward parabola ABC is translating or sliding along. So in there. And we can see an edge view then of our parabola DEF. So that's given by that line there. And if we look over here on our left hand side then, we see the actual parabola ABC, which as I said is sliding or translating along that upward parabola. If we wanted to draw this parabola and this parabola here, we've already covered that in previous videos, and it's just basically a junior sort of construction. So if we looked in at our plan, we've covered this in the previous video as well, that if we take a horizontal section, we're resulted with two hyperbolas. You can see that there, then on the other side as well. So looking down on the plan, we'll see two hyperbolas. It's not very easy to visualize there and that, but we can see it a bit better here. What I wanted to know then, was there any other way we could find points for the hyperbolas rather than drawing in a hyperbola here? So what we notice as well, like that if we take vertical sections, we're given parabolas. So you can see that there in the blue. So like what I thought was that every time we take a vertical section, so we're given a point there, there, there. So if we took more of these then, I realised that it would probably give us the points that we needed for the hyperbolas in plan. So what I thought then was, what I noticed was that if we take vertical sections in our elevation, so just take our vertical section here, the height H, if we step it off from our vertex B, not from the XY line now, but from the vertex B, we step it off from B, because as we said, that downward parabola is moving along that upward parabola, so it's going from point B down this way. So we step off our distance H from the vertex B, so I'll just show that there now. So that vertical section here, height H, stepped off from the vertex B, so that'll give us that point there. So then if we extend that across to hit the parabola on both sides, if we take half that green width in, so take that there, and underneath the line EFD in elevation, if we go to that and planned in, along our center line, if we stepped it off on either side, that'll give us a point on either side of the hyperbolas. So the same can be said then, exact same thing to find other points. So looking at H1, that distance there, if we step that from our vertex B, bring it down here, that'll give us our red W1. So take half that directly underneath H1 in plan. So half W1 struck from the center line. So that'll give us 2 more points. The same can be said then for H2. So then once we have enough points, we can freehand in the two hyperbolas. So I just thought that was a nice principle there. Looking back at this there again. So horizontal sections give us two hyperbolas, and vertical sections give us parabolas.